Okay. Hello, everyone. Time is up. Let's start the meeting. We'll spend 30 minutes for the meeting. And first of all, I will spend 15 minutes to briefly summarize the chapter 1, the introduction and pharmacodynamics. During my lecture, if you have questions, you can type down in the message, okay? I will answer you after the lecture. So pharmacology is the first subject that you get in touch with drug. So what is drug? First of all, you have to know the definition of drugs in the pharmacology. So drug actually broadly defined as any chemical agent that affects living protoplasm and produces a biological effect. And what's the difference between drug and poison? Actually, all the substance could be poisons. That means any drug could be a poison. There is no distinct borderline between drug and poison. The dose actually differentiate drug between poisons. That means if you use large dose, any drug could be a poison with overdose. So what is pharmacology? Pharmacology actually born in the middle 19th century. It is a subject that study of how drugs affect the biological system. There are two main areas for pharmacology, the pharmacokinetics and the pharmacodynamics. For PK, which is pharmacokinetics, it is mainly focused on what the body does to the drug. But for the PD, which is pharmacodynamics, it mainly focused on what the drug does to the body. So today we mainly introduce pharmacodynamics. Okay. How to read? So here is a photograph showing the relationship between dose and effect of a drug. And this effect, dose and effect can be separated into PK and PD. Here you can see the drug concentration provides the link between PK and PD. And for PD, it mainly focused on the effects of the drug. And for PK, mainly focused on the ADME, which is the absorption, distribution, metabolism, and elimination of the drug in our body. So for PK, someone raised your hand. Maury. Okay, let's go on. For pharmacodynamics, I summarized the 4 aspects for PD. Okay. The first one, for pharmacodynamics, the first main part is what effects does a drug have? And the second is how does the drug have the effects? And the third will be the relationship between drug concentration and effects. The last is the regulation of drug effects. Due to time limited, So I briefly introduce the 1, 2, 3 part of pharmacodynamics. So the first one, what effects does a drug have? For any drug, it both have we wanted effects, that is therapeutic effects, and in the meantime, a drug can also have unwanted effects, that is called adverse reactions. So that is the duality effects of a drug. For therapeutic effects, there are etiological treatment, symptomatic treatment, and supplementary therapy. For adverse reactions, we call ADR in brief, they are mechanism-based ADR. What is mechanism-based ADR? That is, this adverse reaction actually is the extension of pharmacological effects. For example, side effects, toxicity, residual effects, and withdrawal reaction. This adverse reaction can be predicted by the drug action. If you have known the mechanism of the drug action, you will predict the mechanism-based adverse reactions. And for the non-mechanism-based adverse reaction, that is, have no relation to the drug mechanism. For example, the allergic reaction and idiosyncrasy. The definitions of these adverse reactions you have known. You can find this definition in book. And the second part for PD is how does the drug have its effect, which is the mechanism of the drugs. So after thousands of years exploration from the experience to experiments, we know that the drug have its effect, not magic. The effect of most drugs result from their interaction with its receptor. We call drug receptors. Actually, drug cannot create new response. Drug have their effects through altering the rate or magnitude of an intrinsic cellular or physiological response by binding to its receptor. There are a lot of types of receptors for drug. Actually, the most common receptors for drug are membrane-bound receptors, including GPCR and ion channel, and a lot of transmembrane enzymes, and also some nuclear receptors or intracellular enzymes could be drug target or drug receptor. Okay, so as we know, drug exert its effect have to bind to its receptor. So drugs that bind to its receptor and mimic the endogenous effect are termed agonists. So there are two steps for drugs effect. The first is binding to its receptor, and the second is to activate the receptor. So we use affinity to define the first step, binding step, and we use efficacy to define the activity, the ability for a drug to activate the receptor. Here is agonists. For antagonists, the drug have the ability to bind the receptor. That means it has the affinity to bind the receptor. But after binding to the receptor, antagonist has no activity to activate the receptor, or has the ability to block the action of an agonist. So this kind of drug we call antagonists. Summarize, the receptor occupation is governed by affinity. and this affinity is different from different drugs. And this affinity can be calculated by in vitro experiments. We'll talk about later. And for the ability to activate the receptor, we use this parameter called efficacy. For efficacy, some books refer to it as intrinsic activity. So both agonists and antagonists possess affinity, but only agonists have the efficacy. Antagonists has no efficacy. Agonists can be further divided into full agonists and partial agonists. For full agonists, which can exert the maximum effect, but for partial agonists, even 100% occupancy of the receptor, the drug can only have partial effect. So the efficacy will below 1. It is called partial agonist. Okay, so as we know, most of the drugs exert its effect through binding to a receptor. And for most of the drugs, binding to the receptor is reversible. So this equation is reversible. The free drug, D means the free drug, R means the free receptor, and it can form a complex, and this reaction is reversible. So this reversible reaction actually obeys the law of mass action. So based on the law of mass action, we can have this equation. The dissociation rate, K2, divided by K1 means the association rate. This is a constant. The ratio of K2 and K1 is a constant. We name it KD, which is dissociation constant. From this equation, we can have this one. DR means the drug receptor complex divided by the total receptor, RT means the total receptor, equals drug concentration divided by KD plus drug concentration. Okay. From this equation, you can see if this equation equals 0.5, that means here DR and RT ratio equals 0.5. If this equation is 0.5 equals 0.5, KD actually equals the concentration of drugs. So here, the definition of KD actually is the concentration of drugs that binds 50% of the receptors in the system, because this ratio is 0.5. That means drugs receptor complex accounts for 50% of total receptor. Okay, and this time the drug concentration equals KD. So the concentration of drug that binds 50% of the receptors in the system, that is KD. So we use KD to represent drug affinity. And this drug receptor binding kinetics can be calculated in vitro by experiments. We use radio-labeled drugs and isolated receptors, and in vitro we can draw this curve between drug concentration and the binding capacity. Okay. From this curve, you can see if we plot the curve and graded range scale, the curve shape is hyperbolic shape. If we plot it with a log concentration, this curve can transform to a sigmoid shape. Okay, so in the sigmoid shape, the middle portion of the curve is nearly linear, which will be easier for the calculation. From the curve, you can see the Bmax, which means the concentration of the drug that occupancy 100% of the receptor is Bmax, and the Kd, which means the drug concentration that can occupancy 50% of the receptor. Okay, we have mentioned that drug have its effect through binding to the receptor. So there is a theory called occupation theory of drug receptor, which means the drug receptor complex can have effect. So this dr means effect. And the total receptor, if total receptor are occupied by the drug, it can has the maximum effect. So this is Emax. So E and Emax ratio will equal here. So that's why here from this the below photograph you can see the drug concentration and binding curve is similar to the drug concentration effect curve. It is similar. And the Kd, which means the drug concentration that caused the drug concentration at which the receptor occupancy is 50% in here. And in Fig A, you can see the drug concentration at which effect is 50%, we call EC50. So in the drug concentration effect curve, here is EC50. But in the drug concentration binding curve, here is Kd. In some situations, Kd can equal EC50, but in some other situations, Kd does not equal EC50. So here I will give you a question. You can find the answer in the books. In what circumstance Kd can equal EC50, and in which situation EC50 does not equal Kd. Okay, here is the concentration effect curve, which is similar to the drug concentration and binding curve. If we plot this curve and a graded scale, the curve is a hyperbolic shape. If we plot this curve and a log scale, here is a log concentration, the curve can change to a sigmoid shape. And in the middle portion of the sigmoid shape, it is a linear curve, so which is easier for us to calculate the parameters. And in the concentration effect curve, there are three important parameters you have to know: the threshold, and the slope of the curve, and the maximal effect. Okay, here is a photograph showing the concentration effect curve. You will know the efficacy, which means the maximum effect of the drug, and the minimal effective dose or effective concentration, which is also called the threshold, and the EC50, the definition for EC50, and the slope. The slope of the curve, which which means in a limited range, about 20% to 80% of the effect. In this range, the drug effect is linearly correlated to drug concentration. And drug potency. The drug potency means the amount of drug that is needed to produce a given effect. Okay. It is used to comparing different drugs that can have equivalent effects. Okay, so we could use the potency to determine the equivalent effective doses of various drugs. And here is another parameters you have to know is therapeutic index, which is the TD50 and ED, the ratio of TD50 and ED50. I have summarized some important parameters in the pharmacodynamics. For example, the graded dose response curve, and the EC50, ED50, and the KD, potency, and the therapeutic index. And also, you can get the electronic books from our library. Here is the website address, and you can download from here. Okay, that's all. Does anyone have question? If you have question, you can raise your hand and I can unlock your microphone.